The clicker. Hi, so I'm Avi Shaked, and this is the work that I've been doing with Sanju in the University of Oxford about automating the security analysis and design of systems using models. Uh, and this is also supported by our industrial partner, Or Jakubovic from Johnson& Johnson. Just to give you a brief overview of the state of the art, is that okay? Yeah, sometimes can't hear myself. Okay, so as the state of the art, we rely on two existing solutions, model-based solutions. So the first one is trades, which I previously developed, and you can see the line below. But this is basically a model-based domain-specific methodology for doing security analysis and security by design. And you can see that there are different representations relating to different stakeholders, and there's an information model being created, and these representations are synchronized based on the information model. And this is an open source tool, and while it can accommodate different security analysis methodologies, it doesn't have any automated analysis capabilities. So we looked into how can we improve that, right? So we have the model that can accommodate the analysis, but not the automated analysis itself, so you do it manually today. And what we found was a thing called, another methodology or method called Verdict, and it's based on AADL, which is Architecture Analysis and Design Language. And you can see some similarities maybe to SysML v2, because it has a textual modality, where you can input your, and it relies on that textual modality to input your system level designs. And what Verdict does, so, and there's an open source tool environment for that called Osate. And what Verdict adds is a security supplement. So you can see all the blue attributes, for example, and properties here. And this is something that is added by Verdict and eventually allows to do automated analysis, which results in some of its results is attack defense trees. So what you see here are possible attacks. So these are attacks from KPAC, which is a MITRE repository of threats or attacks. And you can see the security controls that can be used to mitigate them. So this is what the analysis gives you. But there is no inclusion of threats or risks in the model itself. So this is the model, right? You only see the system design. And this is like a graphical output. You have it in textual output, but this is not a model. And the analysis results are also not in the form of an informational model, just like I said. But you do have some allocated security controls to the different components. This is the this is one component. This is a proposed security control. This is a component, and this is the associated security threat. Found that comforting or reassuring because both Trades and Verdict we came to the conclusion that they share the same domain ontology. And that's nice because they were developed independently, right? So it says that something that we managed to capture the ontology of the domain. And the shared domain ontology consists of hierarchical system composition. That means that you have components in different levels of the system, and the component can include lower level elements, which are components, and they have directed information flows as part of the analysis. They have threats and security controls, and they have the allocations, like I explained here, allocating both the threats and the security controls. So we try to build on that. And our objectives in the project, in this mini research project, was to integrate trades and verdicts so that users will be able to design the systems graphically using trades. And then we'll be able to analyze their design with respect to security rules that are defined in Verdict. And then the system designs will be enriched with the potential threats and the proposed security controls by importing or including the Verdict analysis results in our information models. And what we did was to explore and understand what's beneath the hood of the Verdict, because it was published in papers, but it's hard to understand what's going on in terms of the implementation. I even contacted some of the developers there from GE in the US. Then once we understood what's going on and what are the different constraints, we translated the models from trades into Verdict. into AADL. And then we try to incorporate the verdict analysis output back into trades. So this is basically an exercise in bidirectional model transformation, right? So let's see how it went. So this is one example. This is a very simple system, and you can see it has different components. And we attach several security properties to the component. And we also included a dialog for exporting your model into ADL. This is already included in the trades tool today. There was some kind of a constraint or something that we used a temporary mechanism because we didn't have properties within our meta model for the different components. So we found another mechanism to represent them temporarily. But we will address that in the future. It relates to changing the meta model. I will say something about that later. And you can see this is the this is only an excerpt of the automatically generated ADL. So you can see it becomes very complicated, right? So that's why modeling something like this is much easier than specifying all of these. And this is, as I said, just an excerpt of the result file. And you can see that it has declarations for the different system or components. And then it has another section for implementation. This is the way AADL works. It's like a type and the individual or the instance of that. And some of the properties are actually in the implementation. Some of them are in the declaration. You have definitions for the analysis, for the verdict analysis, and we try to make it as exhaustive as possible. So you can see, for example, if you notice, you have ICA, which is integrity, confidentiality, and availability aspects of security. So we try to include all of them. And in the future, we might try to narrow them down according to a user decision. We have port definitions. These are here. And these are the flows between the ports. So you can see you need to embed different elements in various places. Same for the requirements for the analysis. So this is non-trivial model transformation. And we did it by hard coding this transformation, right? And we were able to automatically generate an attack defense tree, which is, again, it's very exhaustive and very long. I have the full file if anyone wants to see later, but this is very small except from that, right? So in terms of revising the trades model according to this output, we're still working on that, but I hope we can achieve that. It seems reasonable and even a bit less challenging than the previous part. So it's still a work in progress. So some of the limitations and challenges is that we discovered that the verdict design works well only with two hierarchies of system description. So that was quite surprising because they do acknowledge that there are various hierarchies needed there and limited it just to two hierarchies. Seems like they are also just in the prototyping phase, right? So they need to redesign that aspect. I mean verdict. The input and output flows need to be specified, and that's a reasonable constraint because most of the verdict analysis, or even the entire verdict analysis, relies on information flows. So it does not consider any other properties of the system other than information flows. If you don't have them defined, it doesn't do nothing. As I said, we need to add properties to the trades meta model. So we didn't do that for now because we are still working on the meta model to do some other stuff, and we're trying to stabilize it. But as we've seen yesterday, as we've heard yesterday, meta models need to evolve throughout time as you have better understanding of your domain and trying to improve that. So that's something that is doable, and we plan to do it in the future. And as I spoke about the exhaustive requirements, and we eventually want to run the entire analysis without going into the verdict tool, because the entire analysis runs from a virtual container. So we can using an API, we can contact it directly and just run it from our modeling tool. And some of the potential for our work is you can see that in this work here. This is a threat, and I was able to add a new security control to the reasoning used by verdict. and this is a Cherry Pure Cap, and that's something. Cherry is a new computer architecture from Cambridge, which is pushed forward by the Digital Security by Design effort in the UK initiative. And Innovate UK are actually sponsoring or funding us for developing a version of this Trades tool to reflect the benefits of using the, Cherry for security purposes. So this is something that interests them as well. So this is something that is potentially very attractive to include this automated reasoning, showing what threats can be mitigated by using Cherry or other security controls. So I believe that an integrated model-based tool can revolutionize the way we do security by design. So in practice, it's basically a lot of experts moving their hands and brainstorming, and you can do this more methodologically using a model-based tool. With respect to the model transformation challenges, I'm asking maybe some of you, if you know if there is a generic model-driven approach to do that, that can include all the aspects that I showed earlier, so that instead of hard coding model transformations, maybe we can use some kind of DSL for model transformations. That would be interesting in case if it includes all of the cases or if it covers all of the cases that we encountered. So thank you for the MDENet for funding us. This is the website for the Trades tool, and if you have any questions, feel free to approach me.
Thank you very much. This is time for you to ask questions. Clearly, I'm not speaking as loud as Avi.
Thank you for the presentation, Avi. So I just remember seeing your final output with that, large SVG file with the whole tree and everything. Have you looked at interactive visualizations to explore that thread tree and kind of focus on a specific element and so on? Because interactive visualizations. So, okay, I mean, there's something that maybe we can have a chat about because we have a tool for that.
I know nothing.
Okay.
But we want it back as part of the model. Very important.
Mm-hmm.
Get it back as part of the model.
Mm-hmm. Mm-hmm. Okay.
Maybe that can.
Mm-hmm. Okay.
Sorry, that microphone's not on.
Hello? Yeah, there we go. So I was rude enough to unfortunately be outside for the beginning of your talk, so my question might be redundant. But ADL extensions for security have existed for a while. Taking a look at that, there's like a dearth of literature basically that.
So this work was about integrating one of. This work was about integrating one of them, which is one of the latest ones called Verdict, with our tool. So we do use some of that AADL-based capabilities for the analysis, but there are some other aspects like representations that are not covered by these tools.
Yeah, but that's exactly my point, because you're asking about a generic model-driven approach, and I think I don't know if it's generic. I think what is generic is the capabilities that you usually require in order to address integrity, security, and similar things. Also safety, by the way, so there's a lot of comprehensive approaches there, especially with safety. So, worth looking into.
Is that we have a domain-specific solution for modeling security aspects.
Mm-hmm.
And I've already shown that it covers different security methodologies. Mm-hmm. By the way, you mentioned earlier STPA, so I'm working on extending it with STPA as well.
Okay.
But this is a domain-specific solution for security, as opposed to AADL, right?
Yeah.
And that's the advantage of using that information models.
Okay.
The analysis capabilities of AADL is a more formal language. And hopefully in the future, maybe CSML v2, which has a similar textual modality.
Okay. Fair enough.
Thank you.
Thank you very much. Oh, hang on. Stephen asks a question about the meta model changes. Let's not forget that.
Yeah, thank you, Stephen. I mentioned that our meta model just didn't include the ability to add properties to different components or to show attributes of different components. So that is a conceptual element that we will add soon. We are just working on extending the entire security modeling solution with vulnerability management capabilities. So we didn't want to change the meta model in parallel with respect to both. So once we finish with all the vulnerability management related concepts, we will go to include properties as well. I hope that answers your question.
Thank you very much. Let's thank Avi again. And as our next speaker, we have Sophia, who will talk about clinical protocol guidelines and modeling those.
I need this. Yeah. So we are going to do kind of a double act with my colleague that's online, Professor Simon Fraser from University of Southampton. But I will start and then hand it over and then finish as well. This is a SITCON project which we started off this August, but the project officially started 1st of November due to the fact that we didn't have an agreement with King's before. So there were some difficulties setting it up. So the progress I will present is for the last month, and it is work in progress. The team is consisting of 4 people. It's me and Professor Simon Fraser from the medical school, and 2 of master's Bournemouth students, Abiodun and Godwin. At the moment, they are presenting this work at a conference funded by the SITCON project at a medical conference. How do I change? So in a few words, the main purpose of the project is we work on clinical protocol. CKD is chronic kidney disease, and looked into defining part of the protocol so that we can describe it. And the main focus of the project is to evaluate 2 existing DSLs and define the requirements for a prototype DSL. I will continue. Oh, okay, I was 1 slide behind. So I do that recently. I'm on another slide and I talk about the next. So this is the purpose of the project. The secondary goal is to see how this can get applied in educational and medical environment. I think the next part is for Simon. Nuno, can we change? This is all of the work. Yes, Alan.
Hello, everyone. I'm very sorry not to be there in person due to the train strike, but very glad to be part of this symposium. So is it possible, can you see my slides as well as my face? Do I need to share my own screen?
We're working on this, but it might be easiest if you share your screen. Then
I can do that. I can do that. Just bear with me.
Excellent. We can see your slide now.
Okay.
And can the world map?
That's fine. Can you hear me okay?
Yes.
Thank you. So just to give a bit of context, thank you, Sophia, for the introduction. A bit of context about chronic kidney disease, what it is, and why we're doing this work. So CKD, it's a long-term health condition where the kidneys don't function properly. And for many people, it's progressive. It develops over many years. And technically, it's characterized into 5 stages, from mild at stage 1 to more severe at stage 5. And people at stage 5 are often described as being in kidney failure, and those people may require kidney dialysis or a kidney transplant. It's relatively common globally. It affects about 10% of the population. It's more common in older people, and other conditions like diabetes and high blood pressure increase the risk of having it. it's getting more common, importantly, in several parts of the world and having a significant impact. So the map on the right is describing disability adjusted life years, which is to do with the impact that it has on people across the world. It also has a major impact on healthcare, so it's a major contributor to not just ill health but death, and increases the risk of having to go into hospital and using health services, and it has a significant impact on people's quality of life. It's expensive, particularly later stage CKD, because dialysis and transplant are expensive therapies, and therefore there's an argument for preventive care and early intervention because it can reduce the long-term burden and costs. And early detection and management of the condition correctly can slow that progression. And in order to achieve that, doctors need to adhere to guidelines, and sometimes doctors are not very good at doing that. And I can say that because I'm a doctor. So a really important part of this project is that in clinical settings, like in general practice, CKD is often underdiagnosed. And the reason for that is it requires samples of both blood and urine, and it includes the consideration of time. So there's a chronicity element to it in order to establish that it's ongoing kidney problems. So converting that sort of theoretical understanding of what the disease is into logical steps for identifying and managing the disease is not straightforward. And as we've said, there's a risk to patients if we don't do that correctly. And this is important in education because during their initial training, when people are learning to be doctors, and in later professional development, there's not only a need to learn about these steps, but also to change in response to changing guidelines and emerging research findings. So if you look at existing protocols for CKD, they're complicated. So NICE guidance, for example, is over 70 pages long, and yet it lacks specificity on the detail of the practical aspects of that initial diagnosis. Which steps do you specifically take? And we therefore focused on this diagnosis aspect. We set aside the further clinical management of the condition in this seed corn project because it is more complex and there's enough to do just with the diagnosis steps. But we did combine both NICE guidance and KDIGO, which are the International Kidney Disease Guidelines, because they complement each other and are used by clinicians globally. So the novel aspect of this work was really the practical aspects of CKD diagnosis and how that can be implemented in computer programming. We're extending the team with more feedback from kidney doctors and GPs. So apologies that this flow diagram is rather small in order to get it on the screen, but this shows the iterative process that we have been through with the students to convert clinical knowledge about how CKD is diagnosed in practice through a logical series of steps involving conducting blood tests, obtaining results, reviewing results against previous clinical records, classifying CKD according to the guidelines, that's what the traffic light box there is, and then risk stratifying CKD. So in other words, using a risk stratifying equation to assess future risk of progression to later disease. And down the right-hand side of the diagram, there's incorporation of the urine tests as well as the blood test in this whole process in order to get that full diagnostic picture. So the next step then is to model that protocol in an information system and ideally apply it in other information systems. I mean, information systems are well established in clinical practice, and so there needs to be an integration of this in the future. And the ideal outcome is to make sure that doctors get correct and adhering to the protocol recommendations presented to them by the information system. And Sophia is going to introduce the technical solutions and the DSLs. So there are technical challenges with computerizing clinical protocols, so the need for validating and verifying the protocol and incorporating correct by construction requirements. So I'm going to hand back to Sophia now to do the next bit. So I will stop presenting sharing my screen.
And the presentation. Actually got the correct place. Yes. So I will discuss about the evaluation of the DSLs on this. We introduced the subject of DSLs for correct by construction type of usage in this context. And we used two existing DSLs. Proforma is one of the formalims and the other is the GDL. And and the team of the students were from the masters that was medical and IT, so mostly medical. So everybody in the team was mostly medical except me. And I didn't actually help them into creating it because I would ruin the experiment. So that is they came up with in evaluating. The Proforma one, we didn't get very far because it needed advanced technical knowledge to be able to integrate it and bring it into a stage that it would be used by a doctor, because the way you would write some tasks inside the Proforma was like this. We got in touch with the people that developed it, and they were at the University of Oxford, and they actually were very helpful, and they wanted to work on the integration, but to get into the stage to actually use it by a doctor was very, very far. There is a lot of rigor in this formalism, and the results that we have, I said that already. Open Clinical is the company that has integrated Proforma in their tools, and there is an open source part, so it's not impossible, but it was outside the scope of the experiment. So what we found in our preliminary evaluation, because there is more evaluation to come, is that it cannot be directly used by doctors. It is very formal, so it has a lot of rigor, and it actually makes sure that the adherence to the protocol is correct. And my first and my third bullet are the same almost. So that is the original evaluation for Proforma. So continue to work in the guideline definition language, which seem more promising. And the reason it's promising is that it has more boxes in the interface. However, we found out that having boxes can be deceptive. Because the students tried to do that, and it took them learnability of at least 2 to 3 weeks in order to see how they can do rules. So that's one lesson from this. When I originally chose that, I saw the boxes as well, and I thought, okay, the interface is better, so let's go for this one. But when you go to actually create rules in here, you get involved with coding. So, but this is work in progress, and we have created the archetypes, which is the main part of it. If the students could hear me now, they would say she should explain this more, but I really don't want to, mess with it. It has a very important thing that there is this open HR community that creates archetypes which you can use and all doctors can use, which is one of the main benefits. So you can use this open EHR. This is not this part here, where many doctors have created archetypes, which is some templates for several different measurements, and which is a very good thing for standardizing this type of work. So this platform has this advantage, where you can get information for many different things. They are compatible to have this as an input. So this is again the preliminary evaluation. You can get most of the things you need from OpenEHR. You can create your own if you need to. There are details in order to implement your protocol. It is an advantage that there are boxes, so it is attractive still. And then I had from them the general complaint that there is no documentation, there are no YouTube videos. So in order to learn it, the effort is a lot. So the learnability of the DSL is quite low, despite the fact that it actually, the interface looks nice and web-based. This is a slide that I added yesterday, actually, after our discussion. There was some research on DSL evaluation, and these are some preliminary results that we have. And there is a meeting that we plan in University of Southampton mid-month, where we will have several medical professionals and perform some evaluation of this work. So from original research and from my own experience on evaluating DSLs, we have mainly used the work by Kardas in Izmir University in Turkey, which has some quality characteristics which you can use in your questionnaires and assess the DSL. But what I really think that the problem is, despite the fact that we could change this general characteristics defined there and actually make them more acceptable and correct in a community effort. The result of the research is because domain-specific languages are addressing a specific problem, they probably need specific criteria to the domain in order to be assessed. So we are planning to have a separate section with 3 or 4 questions that are specific to the domain, and we call that domain-specific evaluation. Because if you are, and I think that that's the problem that we are facing when we try to evaluate a domain-specific language. It's targeting a specific problem, so it should be assessed on a domain-specific way, if you understand. My inclination is to assess these things with an industrial type of assessment, like does it work, do people use it, so it's good. However, this to be modeled, it has to be specific to the problem. I'm open to discussions about it because I think even if I like it or not, or even if we like it or not, this is something that the community needs and needs it to be more standardized. So our overall conclusions is there is the general usability aspect. These tools have to be low code. So the interfaces and the learnability needs to be improved. The documentation, these are general things that you see whenever you see any DSL. So it wasn't an innovative, a very new outcome. What surprised me is that the GDL, I was expecting it to be more easy because I deceptively saw the boxes interface and thought this is going to be a week's work and they're going to figure out how you do rules in it. And I understood what the problem. And think is that the medical professionals need to be consulted and involved in this work, in the co-creation and co-evaluation, and this is something that is in the purposes of the SITCOM project, so I think we have been succeeding to that for the time being. Yes.
Thank you very much. Thank you, Simon, as well for the online part of this presentation. Are there any questions for or suggestions for Simon and Sophia? Yes.
Thank you for your presentation, Sophia. So this kind of relates a bit to the experience that we had in an on-SITCOM grant where we're trying to get, citizen science project coordinators to use the CSL. and it was actually quite challenging for them to get involved, but because of all the accidental complexity of the ID and everything. So a lot of basically what we essentially concluded is that moving to the web and turning this into more like a turnkey solution where they can just access this link and use something heavily simplified for the perspective would be useful. Have you thought about that? Or have you thought about like moving to the web and all that?
It is part of the project, actually. We have a prototype DSL because this work is a continuation of some previous work we have done for veterinary professionals, but there the clinical protocols are a bit easier, as you can imagine. So there is a prototype DSL which we are going to adjust, but this particular CKD protocol has the issue that it is quite complicated and requires a lot of rigor. So it's a balance between having the doctors being able to use it and actually covering what they need for the protocol. So it is unclear if we are going to succeed and how. We will definitely have a version which has better learnability, and it is in MPS, as you can suspect. Yes. Yeah.
I think I'm going to move us on just in the interest of time because we're falling slightly behind. Thank you very much again. And I'm sure there will be more questions in the coffee break. We now have actually, I think, 2 presentations by Huma, who's been involved in 2 SeedCorn projects. I shall let you choose which one you start with. Or in fact, whether you do them together. There you go.
Okay, so yeah, it's fine. Okay, so hello everyone. My name is Homa Samin and I'm a postdoctoral research associate at Durham University. And today I'm going to talk about of the SeedCorn projects that were funded by MDENet. So the first project that I'm going to talk about is IDecide, quantifying uncertainty in models using artificial intelligence for personalized and shared decision making in digital health. And in this project, I was one of the co-investigator along with Dr. Nelly Bencomo, Professor Dorothy Monacoso, and Dylan Walton. And the second project that I'll discuss is ARIMA, envisioning risk models for assessment of AI-based application. Although I was not directly involved, but I collaborated in developing the risk analysis framework over there. And the other team members were, of course, Dr. Nelly Bencomo, Professor Peter Sawyer, and Dr. Andrew Darby. And in both of the projects, we had an industrial collaborator, that is More Life UK, which is an NHS service that provides weight management programs for dealing with the obesity-related conditions in order to achieve healthy lifestyle goals for the different people. So let's get started. First of all, let me discuss about personalized and shared decision making. Okay, so NHS has presented a model for universal and personalized care in which they think that patients or people will be more in control and will have a choice towards their treatment, and they will decide their treatment in collaboration with the doctor. So what happens over here, we have a doctor and we have a patient, and together they collaborate, they talk, and together they make decisions in order to achieve the patient's target health goals in correspondence with the preferences, values of the patients, and of course, their past health records. Okay, so when I talk about personalized and shared decision making, so the next thing that I'll discuss briefly is our research background, which is actually in the area of decision making under uncertainty. And we have been working in the domain of self-adaptive systems, to be specific. And what we do is that we use models at runtime to offer decision making for self-adaptive systems. That is, the idea is to have a runtime model as an abstract representation of the system that is causally connected to the system being modeled, and it offers reflective capabilities uh, to offer decision making. So when we have a system, so when there is a change in the system, the runtime model changes, and it is the other way around. To be specific, we have been working with partially observable markup decision process to offer decision making in self-adaptive systems. We use them as a runtime model to offer multi-objective decision making. And over here, what happens is that based on the observation and the current state of the system, you select a specific adaptation decision based on the highest utility value for that particular adaptation in order to achieve a certain state or a certain goal. And in case of partially observable markup decision processes, what happens is that it considers the system working in a partially observable environment. So for that purpose, it maintains a belief over the state of the environment of the system. So considering our research background and the case of personalized and shared decision making, the main aims of the projects are, that is, map our experience with decision making under uncertainty from the domain of self-adaptive system to the case of personalized and shared decision making for digital health. And for the digital health, the case study was provided by More Life that was related to weight management. I'll discuss it in a while. The next thing is that risk and value analysis based on the decisions made. So to perform exploratory analysis, to study the relationship of the decisions, treatments, or interventions, and the goals achieved while identifying the risk levels and the utility value of the decision made. And then to decide and develop AI risk model driven analysis framework. So moving towards our first aim, that is mapping the experience with the decision making under uncertainty towards that digital health. The case study that we got from More Life was related to weight management. Okay. So in More Life, what they do is that they provide this weight management program, which is a 12-week long program to maintain or to achieve the specific health goals of the patients that they have. And what they do is that they, based on the symptoms or past health record of the patients, that is based on what is the BMI index. If the BMI index is above 40, so that is the obesity range. Actually, the obesity range starts from 35 till 40. And then if the patients have any other obesity related conditions like type 2 diabetes, high blood pressure, or any other condition related to that. So based on what is the history of the patient and the observations that they have to decide a diet plan or a weight management plan in terms of the healthy diet and the exercise plan for the patients. And of course, once they do that 12-week program, after that, then they have to decide that whether the diet plan was effective for the patients or not, and whether the patients should go for the weight management or weight loss surgery, that is bariatric surgery or not. A decision is taken about that. And then, of course, the weight management post the surgery. So this is what they do over there. So what happens over here, that based on the observations, which are in the form of the symptoms, past health record of the patient, you have to take decisions in terms of adjusting the diet plans or treatments in order to achieve the target health goals. That is, of course, achieving the target weight and minimizing or maximizing benefits and minimizing risks in terms of these obesity-related conditions that the patient might have, such as type 2 diabetes, hypertension, sleep apnea, or any other condition. And it will be, of course, it will vary from patient to patient depending on what the patient wants to achieve. What is the condition that the patient is dealing with? So considering this weight management case study that we have our POMDP model. We say that based on the observation and in our decision making that we offer for the self-adaptive system, we consider states in terms of the satisfaction level of the quality properties or the quality objectives that we want to achieve. So based on the observation and the current state of the system, you select an action considering the highest utility value that you could achieve in order to achieve your target goal. So when we map this, the observations will become the symptoms. The symptoms or past health records or the current situation, current observations that we have. For example, what is the current BMI? What is the specific like glucose level in terms of diabetes? What are those conditions that the patient is going through? Then the states will be represented in terms of